Okay, um, welcome once again. Remember the last lesson I told you we are going to be touching or delving into expected values. In the last class, we treated probability, and we discussed what probability is. We talk much on probability, what it is not, and that and that and that. So today we are going to be talking, like I promised, we are going to be starting with expected values. So in the last video, we mentioned expected values that we are going to be treating it. So you can be rest assured that now we are going to touch it just as I've promised. I believe in the last class you were able to go over the lecture, you know, put down some notes, try to understand the concept, try to remember the concept, if need be, memorize the concept, the terminologies and stuff. So right now we're gonna be going beyond what we did in the previous lesson. So expected values. Now, if let's say peradventure you've not had the opportunity to attend this lecture, what would have come to your mind? Say if I came to you and say, can you tell me um, what you understand by expected values? As in, just give me a layman um, definition of the term expected values. What if we never this lecture has not occurred? Let's assume I encountered you on the road and I asked you, what would have come to your mind? How would you define the term? Well, without wasting much of our time, the term expected values, as we refers to what we expect a specific outcome to be. Say if you run experiments many times, say you run experiment say 10 times, 20 times, you understand, and what do we expect the outcome may be. Okay, let's give it a more statistically profound definition. Let's call it let's say it is the average outcome we expect if we run an experiment many times. You understand? If we run an experiment many times. So look at this definition. We made mention of the word experiment. We said experiment. Experiment. This word experiment is a very important, in fact, it's a keyword in this definition. So we made mention of the word experiment. So experiment in this context does not refer to does not mean the usual or the conventional experiment you may be thinking about, say an experiment conducted in a lab, say chemistry lab, physics lab, biology lab, life science lab, or anatomy lab, or whatever lab. You understand? Here, when we mention experiment in this context, um, we mean the number of trials. Let me give an illustration. Let me illustrate with this example. Imagine we don't know uh, what a probability is while flipping a coin, and we are going to say, maybe we're going to try to estimate it ourselves. You understand? Maybe by flipping a coin, we don't know what the probability will be while flipping a coin. So in this case, we are going to try to estimate it ourselves. So we tend to toss a coin several times, and at every given time, we make that flip. We record the outcome. Say we toss a coin, we make a flip, we got a head, we will record the head. We got the tail, we record the tail. You understand? So at every point of flipping, we record the outcome. So note that the process of flipping and recording an outcome is called trial. Therefore, experiment is what? It's just like it is the process of performing many trials. Let me come again. Let me explain again. We have a coin. We are expecting, okay, let's say the probability of getting a particular thing. You understand? Let's say a coin, when we toss it, we don't know what the experiment is. I mean, uh, we don't know what the probability will be. So, in order for us to know, we tend to what? We tend to estimate it ourselves. And how do we estimate it? For every time we flip the coin, we record the outcome we get from flipping the coin. Say we flipped it the first time, we're going to be recording. Say we get a tail. So say we got a tail, sorry, and we're going to be recording the tail. we flipped it the second time, we got a head. We're gonna be recording a head. So as many times as we can or we could, we're gonna be recording every outcome at every word flipping of the coin. You understand what I'm saying? So the process of the flipping the coin and recording the outcome, that process is called trial. It's called what? Trial. Trial. In statistics, it is called what? Trial. So therefore, we can say experiment is what? Is the experiment is the same the process of what? Performing many trials. It is the process of what? Performing many trials. So if you perform many trials, it is regarded as what? Experiment. So it is quite important to note that when we talk about experiment here, we are not referring to experiment conducted in a laboratory, in the conventional laboratory that you know. So okay, let's say for example, we toss a coin 20 times. Let's say we toss a coin 20 times. You understand? So let's say uh, we toss a coin 20 times. You understand? So, and recorded what? 20 outcomes. You understand? So, the process of um, tossing a coin and recording the outcome is called what? It's called what? Trials. You understand? And the probability of say okay the process of performing many trials is called what? Experiment. So for every 20 I mean for every tossing of coin 20 times and for every recording 20 times, this process is called what? Single experiment with what? 20 trials. Single experiment with what? 20 trials. Note that uh, the probability we get after conducting an experiment is called what? Experimental probability. So when you conduct an experiment, so the probability we get after conducting an experiment is called what? Experimental probability. Let me write it. Experimental uh, experimental experimental probability. Probability. Of course, you can spell probability. So if you're not seeing my writing, please let me know. And I hope this stuff is big enough for you to see. And if it's not, if the visual is too small for you to see, please write it in the comment section or come to me in Discord, send a message to me as to the clarity level, and I will adjust in the next class. And of course, I will find the solution to that. Thank you very much. So like I said ab initio, I said the process, the probability we get after conducting an experiment is called what? Experimental probability. So why the one we introduced in our last lesson, the probability we did in our last lesson is regarded as what? Theoretical, or you can say true probability. Theoretical or true probability. Let me see if I have it here. Okay, okay, I don't have it here. So it is called theoretical or what? True probability. So remember the one we did, the probability we did in the past, where we have the number of possible, the number of possible outcome all over the total number of outcome or the sample space. That one is what? Um, Theoretical probability, or you can call it, another word for it is what? True probability. Let me write theoretical probability. Theoretical uh, probability or true probability. True as in true, the opposite of falsehood. True, being truthful. So we have theoretical probability or true uh, probability. So so experimental probability comes from the fact that we are uncertain. Remember I said, when I gave an illustration, I said we are tossing a coin and we don't know what the expected value might be. We don't know what the value might be. We tend to make many trials. So probability, the experimental probability comes from the fact that we are not certain, or we are uncertain or not certain what the outcomes might be. Uncertain, by uncertain I mean not certain about something, not certain, not uncertain. This is it. uncertain. So we were uncertain about what the outcomes might be. So we conduct experiment. Note that note that the result or outcome we get from conducting experiment are always what equal to the theoretical. Sometimes or most times when we conduct an experiment, when we conduct experiment, uh, let's say uh, the result we get from conducting an experiment is sometimes or most times equal to the what the theoretical experiment. You understand? But it is not always so. But if it is not so, if it is not equal to, it is a great approximation to it. Let's say, for example, during let me give, but it's a good approximation. Like I said, let me give an example. During fuel scarcity in Lagos, when you go to the filling station, or let's say fuel scarcity in Nigeria, when you go to the filling station and to that is you want to go and buy fuel in the filling station, before you leave, you would assume that you don't know what the probability might become, or the probability of that is you don't know what the probability of meeting a long queue might become. So let's assume you might estimate it to be the probability of meeting a long queue is say 80% or 90%. 80% or 90%. You understand? We then, in this case, to determine that it is this, we use what experimental probability. So the formula for experimental probability is similar to that of theoretical probability. The in the we I told you we treated theoretical probability in the last class, so it's similar. Let's say it is the number of, let me see, I think I made an illustration to it. Yes, this is it. The formula for experimental probability, like I said, is similar to that of what theoretical probability, in that it is the number of successful trial divided by what the all trials. All trials in the previous class, now in the previous probability, that is the theoretical probability, was regarded as what sample space. We called it sample space in the theoretical probability. Sample space. You understand? Why that of the successful trial, we call it uh, like the kind of possibility or probability of an event happening, something like that. I can't wrap my head around it, but you can always visit the last lesson and you will see that it is all, in fact, almost the same. Almost the same. But in this case, we use trial instead of sample space. Note that now that we know that an experiment is what an experiment is, we are ready to dive into what expected values is or are. So the expected values of A, let's say we have A, we have a sample space A. So the expected value of A, which is most time denoted by, when we say expected value, this is how they denote it. A, the expected value of A is always denoted as this. Hmm? uh, is the outcome we expect to occur when we run an experiment. And what we are saying here is this. Let me show you. I think let me show you illustratively. I have an illustration to. I give an illustration to that. Okay. This is it here. Let me give the definition again. I said the expected value of A. A, of course, is the sample space. You understand? And expected value is always denoted by this E of A. So, which is this, is the outcome we expect to occur when we run um, many experiments. Sorry, this is what I'm trying to say here. It is the outcome we expect to occur. This is it. This is the definition. I'm giving you the What I was showing there is just before I came here is the formula. So, but I have to give the definition before the formula. You can write this down. The expected value here is saying it is which is denoted by E of A. Remember, E of A being the total number of outcome or number of trials. A being the number of trial, which is the same thing as sample space, is the outcome we expect to occur when we run experiment. This is it. So what we are saying here is that the expected value is the probability of A multiplied by, say, probability of A equals say E of A. No, sorry. We can say E of A equals what? Probability of A, probability of A times N. What it means is that what we are saying here is that the expected value is the probability, which is this equals what? The probability of A, P of A, multiplied by the what? Number of trial. This is the number of trials. You understand? What if I say, what if I give an exercise and say, um, an expected value from a specific number of trial is, say 0.2, no, say 5. Expected value is 5 from a number of trials, so number of trial, and while the number of trial is what, say 20. What is the probability? Of course, what you will do in this case is that, because it's just like you saying, okay, no, since we are looking for the probability from this question that I just said, that given an expected value to be 5 and number of trial to be 20, what is an expected value? What you will do is just give this formula first. Now, to get this one, what you will do is you divide both sides by n, because n is multiplying A. You just divide by n here, divide by n here. This n will cancel this n, so you are left with what? Probability of A equals what? E of A, E of A, E of A, all over the number of what? Trial. So what is E of A in this case? 5. What is the number of trial? 20. 1 year 1 year 4. That is same thing as 1 divided by 4 is what? 0.25, and that is the probability. In case you come across a question like that, so I just say, it just came to my mind now. I said, let me uh, give you let me just explain how you might solve it if you came across it. So this is what we are saying here. This is the formula in case you might want to write it. So let me give an example. For example, imagine you want to get a spade. I want to use this formula to give an example. You understand? For example, imagine you want to get a spade from a deck of cards. Each time we shuffle the cards, say we tend to shuffle the cards 20 times. Let's say we want to shuffle the times 20 times, that the cards 20 times. And I want you to know that you will agree with me that in a deck of cards, we have what? 52 cards. 52 cards. The total number of cards in the deck is what? 52. And maybe the question, okay, let's say the question says we want to get a spade from a deck of cards. What is the total number of spade in the card? If you check, you can go and get a card, you get, I think, maximum of 13 spades. It is what? The number of spades in a card, in a deck of cards, is what? 13. So we now say, imagine we want to get a spade from a deck of card. Each time we shuffle it, each time we shuffle the cards, and let's say we want to shuffle it, say uh we want to shuffle it 20 times, and want to uh make the number of trials to be 20 times. So each shoveling is called trial. So let's say the number of our trial now is 20 times, because you are shoveling it 20 times. Who can tell me from this definition, you can tell what the answer might be, or what the answer might look like? So the expected value here will be what? Let's say E of A equals, what is the probability of A? A is what? the total number of what, is the sample space. Remember, I told you the total number of cards. Shey you understand? So the probability of A will now be what? Let's first of all get probability of A. P of A. Probability of A will be what? The probability number of what, spade all over the total number. So here we will have what? 13 here 1. 13 in 52 should give you 4 times 3 2 12. 4 times 1 it should give you 4. Yes. So the probability here is what? 1 over what? 4. But we use float decimal point. Let's say 0.25. If you punch your calculator and put 1 over 4, the answer you will get is what? 0.25. So expected value will now be what? Probability of A, which is this we have calculated, is what? Is 0.25 multiplied by what? Number of trial. What is the number of trial? 20. So if you calculate this, you will get what? 5. 0.25 times 20, and the best way to do that is return it to fraction, which was 1 over 4 times what? 20. You understand? So 4 here 1, 4 here 5. 5 times 1, 5, which is the same thing. So expected value in this case is what? E of A equals probability of A times the what? Number of trials. And we calculated probability of A here. First of all, find the value of the probability of A. Remember, I told you in this case, because we are using card, the total number of card, which is the sample space, is 2, and the what? Number of trial is what? 13, which that is the number of possible outcome is 13. That is the number of spade. You understand? 13. So where did I get my 13 from? That is the number of spade in what? A deck of card. Where did I get my 52 from? That is the total number of what? Total number of what? Um, cards in a deck, which is what? The sample space. Now, you might be wondering, how did I get this calculation? What if you are given this kind of question? How would you remember total number? No, don't worry. For every question that you might be given or that you might encounter, a value will be provided. They don't assume you might not know anything about card, you might not be playing card. So if values will be what? Provided. That shouldn't create some kind of fear in you. So just be rest assured that values will be what? Uh, Provided. So remember, this definition is similar. Okay, we have talked about that. We have talked about that. So for example, if you are being given this, just know that this is how you will get it, or this is how you will come about it. That this is how you will solve it without having any issues. So remember, to calculate this, I have told you there are 13 spades in a deck of card, and there are what? And the total number of cards in the deck is what? 52. So the probability is 1 over 4. That is 13 over 52, which in fraction, which in decimal will give you what? 0.25. So to get the E of A will now be what? Probability of A, which you have gotten to be 0.5 times the number of trial, that is the number of shoveling, which is what? 20. So this simply means, if you calculate it to get to 5. This simply means we expect to get 5 spade. I mean, we expect to get a spade 5 times for each shoveling, and each time we make our trials. For every 20 trials rather, we expect to have what? Have a spade 5 times. So note that this calculation I just did is when we desire to have a categorical outcomes. But for numerical outcomes, we have different way of getting outcomes when we're trying to determine expected values. So we have the categorical outcomes. Let me write it here. Categorical, from category now. Categorical. I hope you can see this. Categorical. So this is just the categorical outcome. So imagine we want to uh, get that of numerical outcomes. So in this case, this is what is going to happen. In this case, let's say. Yes, this is a case where we'll be using um, numerical outcome. In a numerical outcome, we get a sample space, and each sample space say A, B, and C. You understand? Remember what I told you about sample space. Sample space is the total number of what of outcome. Sorry, total number of data given. Say the total number of, say we have, like we have in the case of card, the deck, the total number of deck, the total number of card in a deck is what, 52. You understand? So it is regarded as what, sample space. And uh, the total number of space, sample space, and the total number of space, I mean spade, sorry, spade is what, 13. So the total number of spade in a card, in a deck of card, is 13, and the total number of card in the deck is what, 52. So 52 here is regarded as sample space. Sample space, this is it, sample space. So don't mistake it for the spade I'm talking about. The spade is just one of the cards in a deck of cards. You understand? So that is that. Don't make that mistake. So like I say, for numerical outcomes, we get a sample space, say A, B, and C. And remember that a sample space is the total number of possible outcomes. Then we then multiply each sample space with its probability. Now, this is a sample space, then multiply by what? In mathematics, dot signifies multiplication. It's same thing as same times in mathematics. So A dot probability of A, this you multiply, the definition I gave says you multiply what, each sample space by its probability. So you take B as well. B you multiply by its probability, then C you multiply what, C by its probability. So to now get, let me show you, okay, this is it in practical. So to now get the expected value, we will now have to get the expected value, we will now have to add, after getting all these, we now have to add everything together. Add everything together. You now have a, let me show you what I have an illustration for it. Okay, this is it. After getting the probability, we now add everything together. So the value we get will now be what, the total number of value we get will now be our what, expected, uh expected uh, uh expected values. You understand? So if you are still confused as to this, please, the comment section is there for you to tell me, or you come to me in Discord, WhatsApp, whatever. Also in our Telegram, you can just come to me in Telegram, on Discord, and just tell me what the confusion is, and I will do my best to explain even simpler that I have that I have just I'll do my best to explain simpler. So, this is the numerical outcomes. How to get a numerical outcome? Remember, we get a sample space, say A, B, and C. Uh, then, like I told you, remember, a sample space is the total number of possible outcomes. Then we then multiply each sample space. A by its what? Probability. B by its probability. C by its probability. Then we add everything together. That is how to get the numerical outcome of an expected value. So So that is that. So expected value, you might be wondering, expected value, where do we find its use? Expected value finds its use in the weather forecast. Weather forecast, because they don't know what the weather might be like, as they are uncertain. So they say something like, expect a rainfall in Kano or Edo State. Expect a sunny moment in Lagos, something like that. So they will always make use of expect, because expected value deals with an uncertain outcome. So expected uncertain, we are not certain of what the probability might be. So it deals with uncertainty. So since it deals with uncertainties, it finds its use in what? Weather forecast, for example. So remember, I said they tend to use previous statistical, and in weather forecast, they tend to use previous statistical uh, data to analyze what their outcome might be. You understand? It's not as if most times it's not as if uh, they see it somewhere or something like that. They tend to make use of the previous uh, statistical data to analyze what their outcome might be, and most times it comes as expected. So in the next class, I'm going to be giving some more exercises. I'm going to be solving some more exercises while we look at how to make future decisions from previous data using probability distributions, using these probability distributions. So we are going to be our next class will be probability frequency distributions. You understand? Probability frequency distribution tells us how to make future decisions from previous data, using previous data. So like I said, the next lesson I'm going to be giving some more exercises, and we're going to be treating some more examples while we look at how to or while we look at this next topic. Before we touch the next topic, I'll make sure in this topic, before I touch it or before I go deeper, I'll give example on more example on how to find the numerical outcomes, or how to determine the numerical outcomes of what unexpected values. With that being said, I will have to appreciate you for your patience in watching this video. God bless you, and please, for everything you don't understand, I've always told you to send me a message in the comment section, or send me a message in Discord, on Telegram, WhatsApp. You all have all those. So thank you for watching, and God bless.